This is the ShiftShapers Podcast, connecting benefits advisors with thought leaders and entrepreneurs who are shaping the shifts in the industry. And now, here's your host, David Saltzman.
You know, as anybody who's looked at medical spend knows, especially recently, musculoskeletal claims are a humongous part of overall medical spend. And sometimes it's kind of hard to think about, like, who's doing anything about that. And the good news is that there are some folks who are looking at that and looking at different modalities and different ways of tackling the problem to try to bring some sense into the picture and to try to bring some economies of scale. They're using things like genomics, AI, clinically informed personalization, and microsegmentation. Now, I don't even know what some of those things mean, but by the end of the podcast, we will. And that's why we invited our guest today, Surya Singh, who's CEO and co-founder of gWell. Surya, welcome.
Thank you for having me. It's my pleasure.
Thanks so much. Now, you're a physician and an entrepreneur. What kind of was the progress that brought you to this particular segment of the industry?
So it goes back a couple steps in my career. And as you mentioned, I'm a physician and have had a long-standing interest in, I would say, the behavior of the human body from a very kind of cellular and molecular level. It's what I originally studied and was very interested in genetics from an intellectual and research standpoint. But I spent a lot of my career really focused on the cost of care and the value of healthcare that's delivered, particularly from the managed care vantage point. I spent 7 years as the chief medical officer of the specialty pharmacy at CVS to that end. But another thread, in addition to thinking about value and cost, and then genetics and genomics and epigenetics, which we'll talk about, is this idea that if we can empower individuals, if we can get people not just to feel accountable for their own health and wellness, but to feel like they can do something to help themselves feel and function better, that is really kind of part of the secret sauce, if you will, to helping people achieve better outcomes. And we often hide it under this word of engagement. We're creating a new program and we want to go engage the individual and engage the patient. And I see it more as, and what really led me to what I'm doing now and what we do at gWell, as empowerment. That individuals can be empowered. Individuals are capable of being able to understand, raise their own level of understanding, and achieve more for themselves in order to both feel and function better.
So that's the personalization and microsegmentation that you were talking about? So
Absolutely.
Talk a little bit about how, let's level set. How big a part of claim spend is musculoskeletal, and what kinds of claims do we see and what kinds of dollars are we spending?
So musculoskeletal is incredibly large as a portion of healthcare spend. So depending on the specific population that we're looking at, and obviously some demographics, what the age is and so on of that particular population on average will have an influence, but it's somewhere between 16 and 25% in the different series of claims that we've looked at. So it rivals very closely other things that we think about as big chunks of healthcare. Therapeutics or pharmacy, for instance, where I spent a big chunk of my career, is another one that's right around the same level of spend. Musculoskeletal, however, is driven largely by procedures and interventions. And I think if you total it all up, there's an organization that's really a consortium of a bunch of different member organizations called the U.S. Bone and Joint Initiative that has the best data on this. Their figure for overall musculoskeletal spend in the U.S. is about $950 billion with
Wow.
a B. So it's an incredibly expensive part of our healthcare spend, and one that continues to grow. And why is it growing? Well, it's growing because population's aging, as we all know. People are surviving longer. And so after you get that first knee surgery, arthroscopic knee procedure, even a knee replacement or a hip replacement, you may outlive it. You may live long enough that you need another one now, where that wasn't the case in the past. And then there's a lot of innovation in the actual types and the breadth of procedures that we can do. And so As that, sort of number and different type of procedures grows, and there's innovation in that field as well, we do more. There's more utilization because we're actually, sort of driving down to people who have lower levels of acuity in their injury or the condition that's being modified or treated. And so there's more procedures being done early and earlier. And when you combine that with what I was talking about in terms of longevity, now you have really kind of this growing spend and a procedurally driven field.
So what you're trying to accomplish is not necessarily looking at hip replacements, but looking at David's hip replacement?
Correct.
So we've talked about, when we've talked to pharmacy guys, and you're an old pharmacy hand, we've talked about pharmacogenetic testing. You mentioned genomics, which is kind of in that same ballpark. How does that help you get down from hip replacements to David's hip replacement? And why do you do that?
Yeah, no, that's a fantastic question. It's also kind of fundamental to how we think about things. So I'm going to take a step back for a second. I will definitely come back to the hip replacement and actually the little bit of the factors and the biologic factors that lead to you needing that hip replacement. But if you zoom out and open up the aperture for a second on what's happening with this field overall, and you mentioned pharmacogenomics, which I've spent a fair amount of time thinking about and analyzing over the years. That runs across, but there are basically three chunks of what people think about when they think about genetics and genomics on the diagnostic side. On the therapeutic side, which I won't talk about as much today, there's a lot of interest, and I have a lot of personal interest in cellular and gene therapy approaches. But let's focus on the testing part of this. So we think about in genomics and genetics, monogenic testing. So, cystic fibrosis as an example, diseases, Huntington's disease, familial hypercholesterolemia, things where there's a specific gene that's been identified, we have an assay for it, we test, you get a diagnosis. That's one chunk of this field. Another chunk that people think about a lot and gets a lot of attention and research funding, rightfully, is tumor genomics. So cancer obviously is fundamentally often a genetic disease, and so the study of that and being able to understand what all the different sort of combinations and mutations mean for people's cancer genetics is really important. That's the second area. And I sometimes bucket separately, although I'll do it as kind of a 2B here. People hear about genetics a lot in the prenatal testing space, obviously, because we use chromosomes in particular, and then genetics in particular there. So it's another place that we think about. But the third area is the one that we're really focused on, that I'm going to talk about most today, and then I'll use this to segue back to the hip replacement example. And that's polygenic assessment of risk and response for common chronic conditions. And polygenic, the word, so multiple genes. So looking at multiple different sites within the DNA. And for almost every common chronic disease or condition that develops, there are multiple genes at play. And not only are there multiple genes at play, those genes are expressed, they are used in different combinations and at different levels by the body in response to what's happening in its environment. And this is the old nature and nurture question. And we often think, okay, it's genetic, so it's part of nature. Nurture is not only, what did you eat and how did you exercise today? It's, sort of all the components of your environment, including what is the hormonal balance that you have, not because of, menopause only or, those sorts of factors. It's fight or flight. How much adrenaline, how much epinephrine is in your body? Which genes are being turned on as a result of that? For how long is that being perpetuated? What does that do fundamentally to the on switch for that gene? And a lot of people think about in this space inflammation, which starts to bring me back to the hip replacement example and back to musculoskeletal or bone, joint, muscle problems. But just to close out on the genomic description, those sorts of conditions that are in my third bucket, where we're really kind of thinking about the combination of different genes, that's where we are focused, and focused specifically on musculoskeletal conditions that affect bones, muscles, and joints. And then to bring it back to the hip replacement example, there are a bunch of genes that have already been validated and specific markers, variants within them, as being important in the development of both osteoarthritis and in osteoporosis. And so osteoporosis, remember, people, I think, know what arthritis is, and osteoarthritis of getting to bone on bone and not having cartilage in between it anymore, and degradation of the actual bone surface, where the bone actually needs to be resurfaced and often replaced, as we're talking about in hip replacement, whether it's partial or full. And then osteoporosis. So one stat that we talk about internally at the company a lot as we're doing our work related to this point around hip replacements and hip fractures is that over the age of 65, about 50% of Americans have a hip fracture. So it's a staggering figure. So, a lot of people end up needing an intervention because of that hip fracture that they sustain. And then of that group who get the procedure, about a quarter, and sometimes a little more than a quarter, are dead within 12 months of their procedure. So it's often the inciting event that leads people to this downward spiral that we really want to try to help prevent. So back to the question of David's hip replacement versus an overall hip replacement. If you have different factors, genetic factors, that are and variants that are at play with respect to both development and then the severity of osteoarthritis and to bone density problems, how we think about the type of intervention that may be best for you, where should they actually attach the hip replacement? That's something that could be influenced in the future by this science. But very tactically for an individual, how do you work to prevent the muscle atrophy that will lead you to have a much longer recovery period? So even in the pre-surgical phase, if it's an elective procedure and not the result of a hip fracture, or B, if many years ahead of time you know that you're at risk from a genetic standpoint of having osteoarthritis and or osteoporosis, we seek to guide you to take different steps and make different lifestyle choices to try to minimize that risk, whether it's vitamin D supplementation, whether it's different types of exercises, with a totally different lens on the motivation for doing those things.
Now, you're also using AI and maybe some machine learning in your process. We talked a lot because obviously there's a lot of curiosity around AI, or the broad field that's usually captioned as AI. How does that help in the process of what you guys are trying to achieve?
So another, sort of important part of of this field and of, trying to figure out, because as you can imagine, if you, again, like take artificial intelligence, AI and ML, machine learning, as tools in the toolkit, instead of as just as they get used a lot, and I think in the industry right now as buzzwords and ways to describe this very, black box. But just we like to think of them as ways to be able to help navigate this vast array of different pathways that can be taken as you try to get somebody from point A to point B in terms of precision health and wellness. And so if you take, sort of back to that example, if we just stick with the example of osteoarthritis and osteoporosis and say there are thousands of different combinations of the validated markers that we know right now, and each individual can have any combination of those. Well, now we have a team of experts assembled to be able to say, here's dozens or hundreds of different combinations of those thousands that are highly relevant. So let's distill it down. We still need to do this phenotypic annotation, and that's another, sort of wonky way to describe. But let's take the form and function that different groups of people have, individuals assembled into groups, and map them to that now, what I just said were dozens or hundreds of genetic signatures related to osteoarthritis and osteoporosis, or broadly musculoskeletal. And through that mapping, we can understand which of those pathways are the ones that are leading to better form and function, leading to better phenotypic outcomes for people. Artificial intelligence and machine learning are a way to be able to do that allows the system to be able to understand better which of those paths are the ones that are really highlighted and are leading people to have better outcomes and better performance over time.
Well, you touched on this briefly a little while ago. I'd like to kind of circle back a little bit about the importance of giving patients tools and understanding. When you were talking about, if you knew that you were predisposed to certain things at a younger age, different courses could be taken so that you don't end up with being the David with the hip replacement. How important is that as part of your long-term project and also as part of day-to-day patient management?
So it's very important. So the follow-up of patients and being able to understand how individuals are doing in many fields is important, but in musculoskeletal, because pain in particular is such an important component of this, and disability or decreased function, which is why I think in the self-funded employer universe, this is such an important topic, because people lose their ability to be able to not just work, be able to function fundamentally, both because of the pain and because of the associated disability, and the two aren't always coupled, but often are. But the patient-reported outcomes, which is kind of the moniker for it, PROs, are incredibly important in musculoskeletal, and being able to track those over time and understand now after the follow-up period, whether it's a month in some cases or whether it's 12 months in other cases, whether the outcome that we're seeing persists and whether the person has really improved and been able to have sustained improvement is incredibly important, both to, the outcome, to ROI, to all of the things that we really want to be able to try to, drive and understand over time. That follow-up and understanding what happens to people after that more precise or personalized intervention was put in place is really important, and it does dovetail back to sort of this idea of it's not the health event, whether it's an injury or, as we've been talking about, a surgery. But just to use a different example, if someone is active and they're lifting weights and they hurt their lower back, or they're working in a warehouse and they hurt their lower back, how they recover from that injury can be very different based on what different techniques and what different therapeutic approaches are used. And I don't just mean injections or a spinal fusion. I mean physical therapy, exercises, and whether or not a tailored program that really takes into account, for instance, which genetic markers they have that dictate whether or not they respond well to eccentric exercise, to weight-bearing exercise, and how long their recovery periods are in between, can really help dictate, are they out essentially from being functional again for 2 weeks or a month or 6 months?
Broad question, but it's the question everybody always asks when you get down to the end of the conversation, which is, what kind of an impact can the work that you're doing, or do you hope the work you're doing, will make on unit cost or overall spend?
So I think if you take everything that we're doing and employ it and put it in place for a population, and that applies to all parts of that Pareto analysis of that pyramid. The people that already have an acute problem, acute on chronic pain, people who have chronic pain, people who are active, or have an active job where they're often lifting heavy objects, or they're active as a weekend warrior, or whatever the case might be, and put them in the preventive bucket. You apply it to all of them. Well, our analysis of musculoskeletal claims says that we can save about a third of overall spending in musculoskeletal. So I think that the effect can be profound, but that obviously has a series of assumptions baked into it. Look, this field is one where a lot of the innovation, as I mentioned, early on, has been in better interventions, which is important. But prevention, as we all know, to use the old adage, is worth an ounce of cure. And maybe the ratio is an ounce of prevention is worth a pound of cure. But, if you say it's 1 to 16, I think it's probably better than 1 to 16 in this case, in some specific areas in terms of health and wellness, when you combine the overall just core economics with the quality of life, with the other part of the value equation, if you take, sort of outcomes over cost. But the other thing I'll say on that point of return is that, this connects back to the individual empowerment idea. This is a field where, and I just talked about in terms of the pyramid, but I would say just more broadly, one thing I worry about in terms of making sure that the impact is as broad as it can be in terms of economics and in terms of value. But also that, to use another little cliche that's used a lot now, that no one is left behind, so to speak. A lot of the analysis that's been done and a lot of the work that's been done in this field so far, not talking about musculoskeletal, but genomics and even at the intersection of those two and genomics in general, has been very available to those who can afford it, not only the ultra wealthy, but the wealthy. It's been very Eurocentric. And so we're a little bit hamstrung by some of the consequences of that now. We don't have a broad and diverse population from which the research is drawn, and we need to shift that. And that's another part of what we aim to do, is broaden access and make sure that that fundamental flaw is rectified before this field gets too mature, because it will have huge and outsized downstream consequences if we're not careful.
Well, that's a great place to end our conversation, but we do hope you'll come back. This is fascinating. Surya Singh, CEO and co-founder of gWell. Surya, thanks for taking time to talk to our audience today.
Thanks so much, David. It's been my privilege.